Hello, I'm Nkosi Smith, and I'm going to be doing a presentation about novel concepts in mechanobiology. This work is adapted from Dr. Nuria Guevara's presentation. So first, I'll be introducing Dr. Nuria Guevara's work, introduce you to AFM or atomic force microscopy, outline the cornerstones in cell mechanics, how to get better data, AFM calibrations, and show some spatially resolved cell mechanics examples. And Nuria Guevara is affiliated with the Royal Microscopical Society and the editorial board of Scientific Reports. She also has a lab where she has done work in mechanobiology and the mechanical behavior of cells. Several of the projects with the lab include image-based diagnostics of drug screening using cell cytoskeleton, assessing the use of the cytoskeleton as a biomarker for health and disease, developing new data analysis tools for image quantification and AFM cell mechanics, the mechanical interaction between the cytoskeleton and the nucleus of the cell, establishing the role of ERM proteins in enabling blood-based directed migration in cancer cells, characterizing the elements of the cytoskeleton that are involved in age-related impaired cell migration and wound healing, and collaborations in mechanobiology and hearing mechanics. So firstly, I'll explain AFM and how doctors like Nuria Guevara use them to study cells. So as it says here, mostly if it's used to measure the mechanical properties of living cells by indenting them. As can be seen in the illustration, there's a very small lever with a tiny spike or bead on it. And what can be done is this lever can be carefully lowered and its position monitored. And as it touches the cell, its deflection can be detected, and that can be used to detect the amount of force. So this slide illustrates the three cornerstones in cell mechanics. So firstly is a good bio-AFM setup, which means that the equipment needs to be set up correctly. There needs to be stability and minimal noise. The temperature needs to be controlled correctly for living cells. The range of the piezo sensors, which are the crystals which, when deflected, give an electric voltage. The range of those piezo sensors needs to be wide enough, and it needs to have correct optical integration. Then secondly, you need a suitable contact mechanics model. So this is basically the model that is used to explain how much force and deflection you expect based on the mechanical properties of the cell you're measuring. And thirdly, you need an optimal data analysis pipeline. So optimization, determination of deflection sensitivity, determination of contact point correction. As I mentioned earlier with the piezoelectric crystals, AFM isn't truly measuring force directly. It's actually measuring voltage, which comes from piezoelectric crystals, which are deflected from being on a lever, which has force put on it by the cell. So also as mentioned earlier with the contact mechanics model, you need to have a link between force and sample deformation to actually be able to measure the mechanics of the cells. So one thing to note is that the AFM doesn't directly measure force or indentation, so you have to be able to calibrate that. So AFM, when properly calibrated, doesn't just measure the force and the displacement of a cell at just one point. It can actually be used to measure this at many points in a 2D grid. So what's gathered with this information is a 1D signal across with the force and deformation on a 2D grid. And this means that since images are also examples of data being placed on a 2D grid, and the grid in real space on the cells is in a 2D region, the data gathered from AFM can be turned into an image. And this means that image processing and filtering techniques can be used on that data. So here you can see the information from these tests are actually being used to figure out the Z height of the cell. And then that is used to produce an image, for which then image processing techniques can be used on it. And in this next slide, you can see that they used image processing techniques to identify and split the pixels from the nucleus and the cell body based on that Z height. And in doing so, you can actually gather specific mechanical information on the different parts of the cell. Thank you.